Welcome to everyone who is attending today. We appreciate you joining us. We're going to be talking about the HD4000. We're going to be doing a software development overview. James and Ian are on board here to present to you today, some of our resident experts on this. I just wanted to go over a few housekeeping rules and a couple of other pieces to note. First of all, I would ask that if you have any questions, that you go ahead and type those into the question box, and we will answer and respond to all the questions at the end of the webinar. If for some reason you have any type of technical issue or you're unable to hear us, you can also post it there and I'll intervene if it becomes a problem for the DevTalk. On occasion that can happen with technology, as we know, but we hope today will go smoothly. Just opening it up today, I wanted to let you know that I'm part of the DevRel team here at Zebra, and we would encourage everybody to join our developer community. You can do so at developer.zebra.com. And it's free to join, and by doing so you can also register and get information on all of our news and events. We have a lot of really cool dev talks coming up, and some other webinars and pieces of information that might be of interest to you, so I encourage you to go to our website and join our community. And with that, I think I'm going to turn it over to James and Ian so we can get this underway. I appreciate everybody joining us today. James, are you ready? Are you there? You should be on mute now.
Yep.
There you go.
Thanks, Stacey. Okay, so thanks everyone for joining. So as you can see, this will be a GTX or DevTalk, I should say, on the HD4000, and we want to give you an overview of the software development for the HD4000. So this is our agenda for this presentation here. So the first thing we're going to do is give you a bit of an overview of the hardware for anyone who's not currently familiar with it, and I'll hand over to Ian to do that. Then once we've got to grasp with the hardware and some of the features available, we'll start to talk about actually developing for the HD4000. So we'll start off with some design considerations, so some things in general we should consider, and then some more specific considerations for both text and icons. And then we'll actually get into the SDK usage. So we'll go through the APIs available in the SDK. So I've broken these into 3 sections: basic, intermediate, and advanced, but don't let that put you off. That's all within the context of the SDK, and everything is fairly straightforward. So hopefully everyone should be up to speed by the end of this presentation. And then finally, the last thing we'll cover is a HUD interface utility application, which we have developed. And it's essentially an alternative way of displaying content on the HUD without actually having to integrate the SDK into your application. But a little more on that later. So first things first, I will hand over to Ian to go through the hardware.
Okay, thanks, James. Can you hear me okay, Stacey?
Can indeed. Yep.
Perfect. Okay, hello everybody. My name's Ian Hatton. I'm a pre-sales consultant on enterprise mobile computing products for Zebra EMEA. And yeah, basically the first slide is really an overview of the hardware in case you haven't seen it already. It's the HD4000, also known as the HUD, which stands for Heads-Up Display. It's basically a single display. You can see at the bottom there, it's a 640 by 400 pixel OLED display. So it sits in front of either your left or right eye, depending on which is most comfortable for you. So most people have a dominant eye, and you would have to position the display in front of your preferred eye. It's a very clear display, although it's relatively low resolution. It does give you a very clear image. It's a ruggedized device. So because it's designed for use in enterprise, it's got a drop spec 1.5 meters to concrete. It's got an IP67 ceiling spec and a -20 to +50 operating temperature range. So designed to be used in warehouse manufacturing environments where you may, for example, have a chill zone or a freezer zone, and you could still use the device in that environment. It's got a microphone built in and also a 9-axis position sensor, so you can actually detect the position of the user's head as they're wearing this display. It's also got an optional 5 megapixel front camera, so that you can choose whether to have that or not. If you have the camera option, obviously then you can take pictures, and you can also record video of what the user's seeing if you wanted to do an application where you need to either view the same thing as the operator, or if, for example, you want to do an augmented reality application where you want to overlay on top of the user's field of view. In terms of power, it's a USB cable to the host device, so it's not a wireless interface. It does have a cable. The advantage of that is that you don't need to worry about charging because it's powered from the host device. Next slide, please, James. Okay, it's not moving for me. Can you hear me, James? Okay, got it. Thanks. So yeah, because it's powered from the host device, you can have a full shift battery life, depending on what device you're connected to. In terms of Zebra devices at the moment, that's pretty much the WT6000 wearable terminal, and also the TC5 series. So TC52, 57. You could use it in other devices. So pretty much any of our devices with a USB-C interface, we can quite easily connect this to. But it does need to be able to provide power to drive the display for a full shift, really. What else? So ease of application, ease of integration, we can talk about that in terms of software. It's comfortable and ergonomic, so it's relatively lightweight. And as I said, you can adjust to either left or right eyes. We also have an alternative mount for prescription glasses, so that you can use it. If you're wearing glasses, you can use the display in front of your glasses. And because it's powered through the host device, there's no staging required. Effectively, all we have to do really is to install a driver on the host device. There's no wireless configuration and no battery charging. Okay, next slide. So these are some of the applications we envision. If you look moving from the left to the right in terms of complexity, on the left side, you've got directed action. So in that case, what you're doing really is just overlaying information on the display. And because the display is transparent, that's basically seen by the user in their field of view as an overlay on what they can see with their eyes. So for example, that could be information about stocking. If you're walking through a warehouse, you could display stock levels. You could display sales information if you're in a retail environment. If you're looking for a product, you could display arrows which guide you to that product. So it's those type of applications where you need to direct the user to a particular location or provide information about a particular location. And then in the middle, you've got AR assisted directed action. So in this case, we add the forward-facing camera in order to capture the video, which is basically what the user can see. And then we can use that to analyze what's in the user's field of view and to augment what they see. So if, for example, they could see a package, then it could provide information about that package, provided it could identify it. And then in the right-hand column, we've got higher solution where we use assisted reality and virtual reality workflows. And in that case, we could superimpose computer-generated images on the field of view of the user. So that's possibly a bit of a stretch with the current hardware where you've got a relatively low resolution display, but that's the direction we're moving in. And I think ultimately we will get to that point with this type of solution. Okay, next slide. Right, over to you, James. Thanks.
Perfect. Thanks, Ian. So let's go straight into then some design considerations that you should keep in mind when designing screens to display on the HUD. So first things first, then some general rules. So as Ian's just mentioned there, the HD4000 or the HUD display is 640 by 400. So the key here with your layouts and your designs is you want to keep them simple. In addition to that, you want to also try and center the content as much as possible, so it's as easy for the operator to see as possible. Another good piece of advice is to use a dark background, preferably a black background. The HD4000 uses an OLED display. So the way OLEDs work, if they want to display a black pixel, they simply don't send any power to that pixel. So if you have a majority black display, i.e. your background is black, then that means that your OLED display is going to use less battery. So you will be able to get more life out of your HUD during a single shift. Fairly intuitively, you want to avoid using a white background. So the first reason would be the increase in battery consumption. And then the other obvious reason would be that it's quite hard to see that sort of color in bright light. So if your operators are using the HUD outdoors, white background is not going to work. We've also found that you shouldn't use blue as the main color for your screens, as it causes eye strain after prolonged use due to the low contrast ratio. And then ideally, you want to be able to use icons where possible. And if it's not possible to use an icon, then you want to use single words with direct intent. So words like cancel or confirm, for example. So on this slide, I just have some visualizations of essentially what I've just said. So the two screenshots or images there on the left, you can see the black text on the white background and the white text on the blue background. These should be avoided for the reasons I've just mentioned. And then on the right-hand side, we've got some examples of well-designed screens, so black background with white text. The furthest image to the right that you can see there, typically you want to avoid long blocks of text where possible, but obviously sometimes that's not always going to be possible. So if you do need to use a long copy, then you want to make sure the text is big enough, and you want to make sure that it doesn't overflow or require users to scroll. So obviously if the user needs to interact with the device to see the screen better, then you're defeating the purpose of having a hands-free workflow. So in terms of text rules, we recommend the text size should be at least 36 SP. Headers and titles should also use at least 32 SP, but we recommend 40 SP as the minimum. For block or body text, the minimum text size is 14 SP. Anything below that tends to be illegible for most people. And then we would recommend using the typeface Roboto, but I guess it's a bit of personal preference. It's one that we found is clear and easy to use, but that's not a hard and fast requirement, simply a recommendation. So again, in the same vein, I just have a few examples of what I mean here. So in the top left, we have the white text on the background. Just to reiterate, that is perfect. That's exactly what you'd want to be doing for the most part. Then we have yellow text on a black background. This is good because we can sort of tie into people's intuition where yellow is associated with a warning perhaps. So if you have a clear direction where you want to warn the user of something, this would be a good design paradigm to use. In the bottom left, we have red on black. So I've put here use with caution. So the red text on the black background is good to use for things like error messages, for example, for the same reason as yellow on black. Intuitively, we see red as an error or a bad font color. So if we use that to denote an error, then it's very intuitive for the user, but it should be used sporadically because the contrast ratio is quite low. So it's sometimes hard to read the red on the black. And then finally, blue text on a background is something that you want to avoid. I can't imagine this would be the first thing that a developer jumps to use, but I think it's worth putting in there nonetheless. And then finally, in the design considerations section, we've got some rules for icons. So they should never be smaller than 32 by 32 pixels, but we recommend using size 48 by 48 pixels. When you place icons on the screen as well, you want to make sure that there's at least a width and height icon separation between the icons, and we would recommend using material icons where possible. Material icons are provided by Google. They're a free resource that you can just go and pull from that link there on the slide. Again, this is just a recommendation rather than a hard and fast rule. If you have a separate icon library you'd rather use, of course, feel free. So to just finish in the same vein again, we have on the left-hand side an example of good use of icons. So you can see they're clear, they're large, there's sufficient separation between the icons, and it's very obvious what they mean. So we know that's home, user profile, and settings. And then on the right-hand side, you can see there that the icons are simply too small and they should be avoided. So that was a quick whistle-stop tour at some of the design considerations you want to keep in mind when you're designing the screens for the HUD. So now let's actually dive into the SDK and go through some of the APIs available. So we'll start off with the most basic APIs available, and these are the ones that you might want to use when you're first familiarizing yourself with both the SDK and the hardware. So the first API to cover would be the show message API, quite obviously used to display a message. So this is by far the easiest API to use in the SDK. You simply call the show message API, pass through two parameters there, two string parameters, one's the title and one is the message. And once you call that method, this is the screen that would be displayed on your HUD, with obviously the text that you've passed through as the parameters for the title and the message, rather than this sample text here. So just before I go on, one thing it's worth knowing that I haven't covered in this presentation, just for brevity, all of the API methods that I'm going to cover in the next few slides are all called on an instance of a Zebra HUD. So you just create a new instance of Zebra HUD inside your application, and then you can call all of these APIs on that instance. So one thing just to bear in mind there. So if you wanted to display an image instead of a message, perhaps, again, this is a very easy to use API. All we need to do is call the show image API and pass through an image in bitmap format. So again, just to reiterate, this would be called on an instance of the Zebra HUD object. As this API takes a bitmap parameter, that means that your image resources are going to need to be converted to bitmap format before that they can be displayed. So this is quite a standard procedure in Android. I'm sure most Android developers are familiar with this. If anyone's coming from a non-Android background, then I would recommend leveraging an image processing library such as Picasso or Glide. These are two very popular, well-supported image processing libraries, and they help you convert images into bitmap format. The reason I recommend using an image processing library is because bitmaps are quite memory intensive to create, and it's easy to make a mistake there. So if you use something like Picasso or Glide, they handle all of this creation for you and the memory concerns, and it just makes things a little bit easier for you. So again, and then the final API to cover under this basic API umbrella would be the API to capture an image. So all you need to do is call the start camera capture API on an instance of the Zebra HUD. And this will return an image in the on-camera image callback, which we can register on the Zebra HUD inside the onResume lifecycle callback. So when I call start camera capture, I will get a bitmap image received in this on-camera image callback. I can do what I like with that image once it's received. Maybe I want to save it to the device, upload it to the cloud. Of course, that depends on your use case. Once I'm happy that the captured image is what I wanted to achieve and I've handled that appropriately, I simply call stop camera capture, and that will finish the camera capture process. So moving on then, just one step up. I want to talk quickly about intermediate API usage. So I only really cover, there's two APIs technically in here, but they're both used to sort of perform the same thing. So essentially, you can use these APIs to create HUD views using standard Android layouts. So if we call this create HUD view API and we pass through an Android layout, so this is the same type of file that you would use to design screens for a normal Android application. We just pass that through to this API, create HUD view. And then the SDK will return us a view, which we can then use as we would in any other program. So we can extract views from within that view object, we can manipulate it and design it the way that we want to for our use case. And then once we've done that, we simply call show HUD view and we pass through that view object, and that is what will then be displayed on the HUD. So this essentially allows custom views with arbitrary complexity to be displayed on the heads-up display with relative ease. So I have an example on the next slide here, which should hopefully put that into a little bit more context. So on the left-hand side of this screen, this area here, we have a text representation of our layout, and then this is what that layout would look like. So we get that preview inside Android Studio. So you can see here our text layout consists of a linear layout, which is the sort of the base layout file. Then we've put an image view, which takes up 90% of the screen. And then we put a text view at the bottom, which takes up 10% of the screen. So you can see there we've got a tick taking up 90% of the screen, and then text down the bottom taking up 10%. So this is quite a simple layout that I've created here. And I've done that purposely to try and make it simpler to explain, but you could make this as complicated as you like, and you would handle it just like you would any other Android layout. So then on the right-hand side, we have some code snippets here of what we would actually do. So the first thing is that we create an instance of our Zebra HUD. Then we call the create HUD view, and we pass through this custom HUD layout file, which is this text file here, which returns us a view object. We can then extract the image view and the text view subviews from this view object, but just by calling find view by ID, which is a standard Android API. Then we can manipulate those views how we want to. So for example, I could set the image resource. So in this case, I'm just setting it as a tick, but we could change it to a cross, for example. And then similarly on the text view, I can just call set text and change what the text at the bottom here displays. And then once I've done all of that manipulation and I've got the screen ready to display, I simply call show HUD view on an instance of the Zebra HUD and pass through this custom view object that we've just created. And then you would see this screen appear as if by magic on your HUD display. So again, this is probably my preferred way of using the SDK at the moment. When we talk a little bit more about the HUD interface towards the end of the presentation, this is the API that I've relied on the most. I think it's very intuitive for an Android developer. It's something people are very familiar with, so it's quite easy to get up and running with the HUD straight away without concerning yourself with the other APIs. But with that said, it wouldn't be a good dev talk if I didn't cover all of the APIs available. So now we'll move on to advanced API usage. And again, don't be disheartened by calling it advanced API usage. This is all within the context of the SDK, so it is all fairly straightforward. So under the umbrella of advanced API usage, all I'm going to talk about really is the JSON image model, or JIM. So this API essentially allows you to use a JSON file to design screens for the HD4000. So in this case, you would create a JSON file, and that would correspond to one single HUD screen. So each screen or each JSON file can have multiple widgets, and these are what make up the content of the display screen. So inside this JSON file, we have an array of widgets, and each of those widgets within that array is essentially a view to display on the HUD. These widgets can either be images or text. Those are the two options supported at the moment. So in the coming slides, I have the JSON schema that we'll go through and some real-world examples as well. So once you've created the JSON image model, or the JIM, which I'll go through in a bit more detail in the coming slides, you would just display that quite simply by calling the show JIM method, and you just pass through the string representation of your JSON file. If you wanted to include images, however, there is an extra step. So you would need to call the overloaded show JIM method. And instead of just passing the string representation of the JSON, you need to also pass through the base images directory where all of your images are stored. So you'll see in a moment in the JSON file, we use a relative file path to point to images, and then we would provide the absolute path in the method. Both of these methods, whichever way you decide to do it, so if you're using text, you would use this one. If you're using text and images or just images, you would use this one. Both of these methods return a byte array, which represents the display content. So you pass through the JSON through to the SDK, it will inflate that, it will parse the JSON, inflate that into a view, and then return that as a byte array to you, representing the display content, which you can then put into an image view on the device. If you wanted to mirror the screen, for example, you could save that view for analysis later. You can do what you like with that byte array. So let's actually have a look at the JSON schema for creating HUD views from a JSON file. So the base JSON schema applies versioning, formatting, and so on to the screen which you show on the HUD. So I have here the top half of the JSON file, and then the next screen I have the bottom half. I've just done this because I couldn't fit it all into a single screen. It would be too small for anyone to see. So just imagine this slide and the next slide are all part of the same file. So this section of the JSON file, as I mentioned, sort of applies the sort of overall or the overview settings for the HUD screen. So we have an option to show a frame around our view, and this would literally just put a border around our view. If we decide to do that, so if we set that to true, we would also need to provide a frame color, and that would just be the color of the frame around the view. And then also we can say that we want this screen to be resized in a percentage format. And these are the 5 percentages which are currently supported: 95, 90, 85, 80, and 75. So on this slide, we have the so-called bottom half of this JSON file, and it is essentially the widgets array. So this is where you really put in the important stuff, and this is where you start to build your widgets to display. So we have this array here, and within this array, we can have as many widgets as we like, and the widgets would have the following properties here that you can see. So the first property is whether this widget should be visible or not, and it takes a Boolean. This is pretty intuitive. It's just true for visible, false for invisible. Then we have the sort value, and this is a very important value to include in your JSON file. So when we put these widgets in the array, we need to tell the SDK what sort of order that we want to put these widgets in. So which widgets need to be further to the back of the screen and which widgets come to the front. So essentially what we're saying here is what Z position we want to have for this widget. So widgets with a higher Z position or with a higher sort value are overlaid on top of lower valued widgets. The next option we have is called type, and this takes an enum value, either text or image. So it defaults to text. So if we just want to display some text, we can leave this out. But if we want to display an image, then we need to make sure that we include that. The next section then is data. So this takes a string, and this depends on what type of widget you're using. So if you're using a text widget, it's quite simply, it's just the string that you want to display on the screen. If you're using an image widget, then it can either be a path to the file, and this would be the relative path, or you could use a base 64 encoded string of that image. So it's up to you. If you want to point to a file on the device, then you would use the file path method. If you want to hard code the image in base 64 format into your JSON file, you can do that as well. The next two options here are sort of an either or. So you would pick one of these two options, and they're both there to describe where you would want this widget to be positioned on your screen. And they do it in slightly different ways. So they're both an array which take 4 items within that array to define the widget position. So in the case of the position item, we have X, Y, followed by width and height, and these all go from 0 to 100. So for example, if we provided an array of 5, 5, 90, 90, that would provide us a widget which is a 5% border from full screen. Alternatively, if we wanted to use the position point item to define the position of the widget, the difference here being that it uses the center X and center Y rather than X and Y coordinates. So as an example, if we were to put 50, 50, 10, 10, so center X is 50, center Y is 50, and the width and height is 10, 10, this would create a 10% width height box with its center point in the middle of the screen. So essentially, you're deciding here whether you want to position your widget from 0, 0 on the axis or from within the middle of the screen. Moving on then, we have lines here. So this is only applicable for text widgets, but it just defines the number of lines that you should use for the text. Down here, we have color. So for text, it's quite simple. It's just the color of the text. For an image, it is the color which would be applied using the Android porterduff.mode.multiply API. So this basically just puts a bit of an overlay tint on top of your image. The string that you pass through for this value is parsed using the Android color.parseColor API. So any color string supported by this API is subsequently supported by our SDK. The next thing then is color back. So this is the background color, so either of your image or of your text view. And again, this is parsed using the color.parseColor. So anything supported by that is supported by our SDK. Bold then is just whether or not you want the text to be bolded. Image scale again is just the scale that you would want to apply to this image. So this is using the Android ImageView.ScaleType enumeration. So these are the options that you have available here, and these would be applied in the same way that the ImageView.ScaleType API would be applied as well. And then finally, we have gravity. So there's 3 options supported here, left, right, and center. And this is the gravity that you want to apply to the text. And it's the same as using the Android View.Gravity API. So I appreciate that's quite a lot of text all on a single slide. It's quite a lot of information all to throw at you in one go. So hopefully the next few slides give some examples where we break this down and it's a little bit easier to digest. So on the left-hand side, we have the JSON representation that we would pass through to the SDK. And then on the right-hand side, we have the image that would be displayed on the HUD as a result of this JSON. So you can see here at the top half of the JSON file here, the sort of base objects, we have the version, which is 1.0. We always need to include that, but it doesn't really make too much of a difference to our screen. And just for simplicity, I've put false for the show frame. So we don't want to put a frame around the view, and we don't want to apply any scaling. And then we get into the widgets array. So you can see here I've created one object within the array, and these are the values for this object. So we've given it a sort value of 70, so a Z position of 70. Because there's only a single widget within this array, it's kind of redundant at the moment. It doesn't matter too much, but it will do in the next examples that I show you. We've put a note here, so this is ignored by the SDK, but it's useful for you as a developer to have there so you know what widget this is referring to. So I've just put instruction string. Given it a position, so the X value is 0, the Y value is 50. It takes up 100% of the width of the screen and 10% of the height. Pass through the data, which is the text that we want to display. I've given it a background color, which is just slightly off black, and I want the text to be bolded. So you can see here that this is what this would create, a view or a widget, I should say, which extends the entire screen. You can see the background color is just off black there. The text has been bolded, and it takes up about 10% of the height of the screen. So that's probably the most simple example I could provide of using a JSON image model to create a screen for the HUD. So in the same vein, I've basically done the same thing in this slide, but rather than displaying text, I want to display an image. So the top half of the JSON file here stays the same for simplicity's sake. And then down in the widgets here, I've given it some different values. So we've given it a sort value of 10. Again, at this moment, it's not too important. I've put a note, so I've said that this is just a background image for slide 1. I've positioned it 0, 0, so down here at the bottom left, and I've given it 100 width and 100 height, so to fill the entire screen here. As you remember, I said that the type defaults to text, but because we want to display an image this time, we need to verbosely specify that the type is image. We've also provided an image scale, which is fit XY. So that just means that we want this image to fill this position dimensions that we've given it. And then finally, the data is the relative path to the image. So if you think back to the slide probably about 5 minutes ago, I said that if you wanted to display images, you would need to call the overloaded API and pass through the absolute path of your images. That would be the prefix to this path here. So for example, if this image is installed in, say, the SD card /HUD demo folder, and then images /engine.png, I would call the API by passing through the prefix to this, this file path. So it would be SD card /HUD demo, and then this JSON file would have the remainder of these images here. So moving on then, if you wanted to combine these two widgets together, here's how you would do so. So again, the top half of the JSON file stays the same, but you can see here now we have two objects inside of our widget array. And this is where the sort value becomes really important. So I've given the image a sort value of 10, which means that I want it to go right to the back pretty much. I've kept all of the other values the same, and then I've just added in the text widget below. And because it has a sort value of 70, that means that the text will be placed on top of the image. And you can see here, that's what we get in the preview on the right-hand side. So we have the image as the background, and then we have the text overlaid on top of it. So if we wanted to take that a step further, and if we wanted to add, say, for example, another image to our view, we could do that just by adding another widget down here. So you can see I've given it a very, very specific position and dimensioning here, and that's because I want this arrow to point to a very specific point on the diagram, and I've done that using this array here. Again, I've passed through the path to the image, and you can see with essentially very few lines of JSON, I've created a fairly complex HUD screen. And then the final example here is just to show you what it would look like if we wanted to include the show frame option. So up here, I've set it to true, and then I've provided the frame color as green. So it's placed a green border around our view. So hopefully that put the JSON image model API into a little bit of context for you. Hopefully that makes sense and lets you get started with playing with the SDK. So that actually brings to an end the SDK or API portion of the DevTalk of the presentation. So now just talk fairly briefly about the HUD interface application we have created. So the HD4000 intent-based interface was developed because there's quite a few popular existing apps. So you could think from a Zebra point of view, things like Enterprise Browser, or from a third-party partner point of view, things like Velocity. These applications may find it difficult to integrate this SDK quickly. So this interface app essentially removes the majority of the work which is required to integrate the HD4000 into your existing application. And it does this by using standard broadcast intents to act as an interface between the HUD and any other application. So it runs as a foreground service, which is constantly listening for these broadcast intents. This foreground service manages all the SDK functions and connection to the HD4000. So there's no need to write a native Java application, and there's no need to embed the SDK within that application. And then when it receives information via a broadcast intent, it will then display that directly on the HD4000. So it will take the intent, it will parse that, and it will turn that into a view for the HUD. And I've got some examples of the intents that are supported in the coming slides. It also quite usefully has an optional screen overlay on device. So it looks something like this. And this is quite useful if you're taking the HUD to, say, a conference or something like that, and you're trying to demonstrate its capabilities. Obviously, by its nature, only a single person can ever wear the HD4000. So when you're presenting to a group of people, you can have the overlay on the device so that you can say, here is exactly what the person wearing the HUD is currently seeing. So you can do demonstrations to groups of people with only one piece of hardware, essentially. This was developed in conjunction with Avanti, so we work closely with the developer in Avanti to sort of iterate the versions of this interface, and it's tested and working with Enterprise Browser. So moving on then into what intents are supported. So if you want to display text using this intent-based interface, this is the intent action that you would call display text. These are the extras, and these all are in string format. So even the size is a string, it needs to be wrapped in a string. And these are the 5 extras that you would include to define what you want your text to look like. So text.text is just the data that you want to display, so the text to display. Text.color is the color of the text, the size, the justification, so left, center, or right. And then the text background color is the background color. So again, these are all relying on the same APIs that the GIM would rely on. So any color supported by color.parseColor is supported by the interface app. And again, any justification used by the Gravity API is also supported by the interface app. So down here you have an example of how you would send this intent from ADB. So you might not want to do it from ADB, but it's useful for testing. And you can see there that I've put through pick item. I want the text color to be black, a size of 12. Put it in the middle for me and put the background color as yellow. And this is what it would end up looking like. So we have a yellow border here, which defines the HUD view. So this is an exact representation of the HUD view. And then this line here is our line of text that we've just sent via the intent. So you can see there it says pick item, black font on a yellow background. Alternatively, if you wanted to display multiple lines of text, you would simply send a different extra set to the same intent action. So the action remains as display underscore text, but instead you just pass through one extra, and this one is text.array. So this is a single string which takes the format that you can see here. So it's the data you want to display separated by a tilde, and the color, tilde, justification, tilde, background color, tilde, size, and then a pipe to denote the end of that line of text. And this format can be repeated indefinitely. So I've got an example down here, and this is what would be used to display this screen up here. So you can see I pass through one string extra, which is text.array, and then I have my title text here. I want the text to be yellow. I want it to be in the center with a black background, and because it's my title, I want to give it a font size of 16. Then I've put through a transparent empty line of text here to make this separation. And then I've just put through 3 more lines of text, body text 1, body text 2, and body text 3, which you can see just there. So that's an example of how you would send multiple lines of text using a single intent. We also have support for displaying images. So in this case, you would call display underscore image. You would send the intent, sorry, display underscore image, and these are the extras that you would pass through. There's only one that's required, and this is the absolute path to the image on the device that you want to display. And you can also override the width, height, and scale type. So these default to 640 by 400, which is the full size of the screen, the HUD screen. And the scale type falls back on fit underscore XY. So you can override those values if you like. This is an example of how you would call this, this intent. So you can see here, I just passed through the full path of the image that I want to display. And then this is what you would see on the HUD itself. If you wanted to combine the two, if you wanted to show images and text, you would call the display text and image, or you would send the intent using the display text and image action. And you would just basically pass through the same extras that you would for an image and the same extras that you would for a text, but you just put them into a single intent. So that would be the path to the image on the device, the text that you want to display, the color, the size, the justification, and the background color. And then that would be an example of how you would do that down there. You could also make it slightly more complicated if you wanted to. If you wanted to display 2 lines of text and an image as the background, you would do the same thing. But rather than using the verbose text extras, you would call the text.array extra. You would use the same format as you would when you were displaying text. So you can see down here, I pass through the text array. I've got my title in there. I've got a transparent block in the middle here, and then the final set of text down the bottom there. So that's displaying text and images in a single intent. And then finally, we also have support for the JSON image model that I've just talked about. So you would just call display gym, you would pass through the JSON that you want to display and the directory of those images for the relative path images that you provide within the gym. So the example of this is just down here. So you can see I've put through the gym with some escaping for the ADB, and then I've passed through the image directory, which is in this case SD card download, and then it will find printer.jpg within that directory. I've also got a few extra intents which we support for doing some useful things. So if you want to clear the display between intents, you can just call this intent here. So just call clear, and that's an example of how you would do that. If you didn't want to verbosely send an intent in between your intents, so let's just say you've displayed an image, then you want to clear it, and now you want to display some more text afterwards, you could condense that all into a single intent just by adding this caret symbol before the data field. And that will clear the previous intent or the previous view that's shown on the HUD, and then it will replace it with this new intent. Otherwise, it will be appended just below the last data that you sent. So an example of that would be here. I put the caret before the data, which in this case is the image file path. This is the same procedure, be it text, gym, or image. Just make sure that that caret is the first thing that you get. And then finally, you also have the option to toggle overlay. So the overlay that you see on the screen, which gives you a representation of the HUD screen, that's optional. You don't have to have that enabled, and you can toggle it using the intent there, toggle_overlay. So I think with that brings to an end my portion of this presentation. So I'll just hand over to Ian to go through some of the demos that we've created using this HUD interface application.
Okay, thanks, James. Yeah, so there's just some samples here using this interface app with other applications. First one being Velocity, which is from Ivanti. What you can see on the screen there is an example of how in a Velocity script you can call the interface app through the action.sendBroadcast script command, and then pass through the action that you want, in this case displaying a single text screen, and then in the extras you put the parameters that James has just described really for displaying text. The barcode you can see there is a Stage Now barcode, so that's internet hosted, and what that means is you can take any of our devices, preferably something like TC52, 57. You can read that barcode and it will install Ivanti, Velocity, and also the interface app, and you'll be able to actually see how it works on a device using that barcode. Go to the next slide, thanks. So you can see here some screenshots, some notes on the left-hand side, ensure that the interface app is running. So you need to have two apps actually running. One is the 615 driver for the HD4000, and also the interface application itself, and those will both be accessible through the notification bar, which you can pull down from the top of the screen. In terms of the demo itself, when you run Velocity, you'll have two host profiles. One is a demo, the standard pre-canned demo basically that runs without requiring a server connection, and the second is the same demo but with voice enablement. So if you want to run the second demo, you also have to install the Speakeasy add-on for Velocity, but for the first demo it will run as is, and you just can drive the demo either through scanning barcodes or through using the buttons on screen. So to actually see the demo running, you select warehouse, outbound, and then pick to tote. And then when you press next task to skip the barcode input, it would show you the location on the screen that you can see in the center image there. And that's the interface app showing basically exactly what you would see on the HUD display, but on the display of the device. And that display itself, that overlay, you can turn on and off. So in this demo configuration, we've got it mapped to the PTT key on a TC5 series device in order to toggle that overlay on and off. And you can also reposition it. So if it's in the wrong place on the screen, it's hiding, for example, a button that you need to press, then you can just drag and drop it in a different location, or you could toggle it off in order to access something underneath. So basically what it shows is the picking location, the aisle, bay, and level. And then when you press the scan button to confirm that you're at that location, it shows you the picking quantity. And you can press the confirm pick quantity to actually accept that quantity. So yeah, pretty easy to use. Big advantage is you don't need to have an HD4000 in order to show the concept to somebody, because they'll see exactly what you would see on the HUD on the screen of the device that you're using to demonstrate. Okay, next slide. So in the similar way, for Enterprise Browser, again, we can use some JavaScript to send the broadcast intent to the interface app. A couple of samples there. First one just clears the display, and the second one displays some text. So there's a simple demo for that we've put together. I'm not sure if we've got stage now code for that, but basically it's pretty straightforward, uses exactly the same concept, but just a slightly different format for the scripting in order to drive the interface app from Enterprise Browser. Okay, next slide. Some other options. So basically most development environments, as long as they support sending a broadcast intent, they will allow you to easily interface to the HUD using this method. We have tested that with 4GL from ISV called SysDev in Portugal. It's called Calypso, that's their product. Since we put these slides together, they've actually included the full support for the HD4000. So you wouldn't need to use the interface app now. It's actually built into their development tool. So if you're looking for a very simple way to build applications without having to actually write Java code or JavaScript or similar, then it's interesting to take a look at that, because that will give you a pretty full-featured support for the HD4000. We've also tested interfaces to Adobe PhoneGap, so that's an easy way to actually drive the HUD through JavaScript. And another scripting tool called DroidScript, which allows you to write in JavaScript, and again, very simple to interface to the HD using that method, the interface app from those development platforms. Okay, next slide. Just some examples of some sample apps created with the interface. So this one just does a slideshow. So you can create your own slideshow. It's got a slides.ini file on the SD card, which contains the image path and the text to overlay. And in this sample setup, we've just got it running through how to replace a print head on one of our printers, just as an example of how that could look to a user of the HUD. Supports voice command for advancing and going backwards and forwards through the slides, which would be useful if you want to have, a completely hands-free interface for the user. The Stage Now barcode at the top will install that app if you want to see how that works on a device. And next slide. And this was just really a kind of proof of concept of a translator. So this uses a UDAO, I'm not sure how you pronounce it, UDAO Translation Service API, which is a kind of open source translator you can easily interface to, and it's going to support, it will support translation of an input language, which is any of the eFIGS languages, which is English, French, Italian, German, Spanish, to any of the eFIGS output languages. So the idea is you speak in your local language, if it's one of those 5 languages, and you can choose which language to translate to. And the translated output is going to the HD4000 through the interface app. So if you were in an example where you had custom facing environment, you were basically had people talking to you in different language, then potentially you could have the translated text appear on the screen of the HD4000. Again, that Stage Now barcode will install that and see how it works. So that is pretty much it. Any questions from anybody on the call?
Yes, we have quite a few here. Let me see. The first one from Dave. He's asking if there's a basic demo APK to see the camera video on the TC51 display. Is one available?
Do you want to take this one, Ian, or shall I?
I don't know of one, so maybe if you take it.
Yeah, I don't know of one either. I don't think we do have one available, I'm afraid.
Okay.
Not out of the box, so no would be the answer.
Okay, Nico asked design considerations. There was a talk about black background. What about transparent backgrounds?
Yeah, you have to provide a background to the screen. It can't just be transparent, I don't believe. So we would recommend you fall back to black.
Okay. CMAC asks show image API. Does it resize to the display full size, or do we address where in the screen to show it?
So that would be where you would use the scale type. That's where you would use the scale type for displaying that image. So when you place show image, you can define what scale type that image should be.
Okay, and regarding the API usage, create HUD view, does it allow for dynamics drawing? It looks like it's creating a view and then refreshing the HUD display.
If by dynamic, if you mean moving content within that view, that won't work. So once you pass the view to the show HUD view API, it will basically create a JPEG representation of that view and then display it on the HUD. So if you had any moving content within that view, it would just show a snapshot of that moving content.
Okay, and this question's a little, not sure the typos in here, but are underlying implementation for show image and show gem APIs the same?
That is a good question. I'm not entirely sure. I would have to go and review the SDK. I don't know the answer to that off the top of my head, I'm afraid.
Okay. What is the advice for asking for quantities? How to handle user input that cannot be scanned? What it's referring to?
I think probably voice is the best option in that case.
Yep,
oh, sorry, James, go ahead.
No, sorry, I was just agreeing with you.
Okay. Are there any augmented reality demos? AR demos?
No, not at the moment.
Okay.
Yeah, it's still fairly early days in terms of, building out a set of demos for the product because it hasn't been on the market for very long. So I think it will happen over time that we'll have a full set of demos, but not currently.
All right, good. Those seem to be all of the questions for today. I just want to remind everyone that we did record this, so we will be posting this onto our YouTube playlist, and we'll add that to the blog on our dev portal and announce when that's posted within the next couple of weeks here. So James, Ian, thank you for a really in-depth, informative webinar today. If nobody else has any other questions, I think we're good to wrap this up and look forward to seeing everybody at the next DevTalk in mid-July.
All right, thanks, Stacey. Thanks everyone for joining. Speak to you all soon.
Yep, take care.
Take care. Have a great day.